Okay, let us see what we have here now. We have one glider, this one, that is moving to the right with the speed of this one. Okay, one glider that's moving to the right with the speed. A frictionless horizontal air track. Then this glider has collided with this one that is moving to the left with this speed. Okay, find the final velocity of each glider. Find the final velocity of each glider in the collision. If the collision is elastic, let's draw something like this. You have some frictionless surface. Let's say frictionless surface, and you have one glider here that is moving in this direction, and that is what we noted as M1 0.151 kilograms, and its speed V1 is 0.88 meter per second. Okay, and we have another glider that is moving in opposite direction with mass M2 is equal to 0.301 kilograms, and its speed is V2. And now, why did I put minus 2.3 meters per second? Why? There is not mentioned to be minus here. Okay. And V2 is minus 2.3 meters per second. Why is that? We will have here motion in one direction, in one dimension, all the time. So we will say this is x-axis. All the motions is here. If the speed is positive, then it moves in direction of the x-axis. If the speed is negative, then it moves in opposite direction. So whatever moves left, we will note like this. Whatever moves right, we will note like this. And furthermore, when we get the result, we will get something, let's say V2 is equal to plus 10 meters per second. Let's say. What does it mean? That means that it will go in this direction, and this will be its speed. But if we get V2 prim is minus 10 meters per second, that will mean that this object will go to the left. You know, all there is to it. How much is it? We don't know that. No. How much is that? For now, we don't know that. But this is a starting point. And we will have elastic collision. That means we will have conservation of momentum and conservation of energy also. Mechanical energy. Energy is always conserved, but mechanical energy is conserved with elastic collisions. Okay? And what does it mean? This is equations for the conservation of momentum. This is prior to impact of the first object and after the impact, and prior to the impact of the second object glider. This is after the impact. Okay, we know this, and this, and we don't know this one and this one. So this one is unknown to us at this time, and this one here is unknown at this time. At this time. Try to make that a little prettier. And this V2 is also unknown. So we have one equation and two unknown magnitudes. But luckily we have a conservation of energy also. And this is prior to impact of the first body and the second body, and after the impact of the first and the second body. And as you can see, this is V12 and V2 is here also. So one equation, second equation, and two unknown magnitudes. These are the speeds that we need. Now, you could use this. You could put all of these known things here and here and here and here and here and here and here, and then try to solve it like a normal human being, and that's all. But we are the teachers, and we like to complicate things. So we will simplify these equations, these two equations, and try to find some errors. This is commonly used in this kind of operation. So let's see how we're gonna simplify those two equations. Okay, first one we will just rewrite it down as this. You see, we move this from this side equation and this part on that side equation, and it became like this. So just change the sign when it goes over the equal signs, this situation, and this situation also changes the signs. So that is, now we draw in front of the brackets this and 1, and inside we have v1 minus v1 prime, and m2 also, so we have v2 prime minus v2. So this is the other way of saying these things. It's the same, doesn't matter. Now we will rearrange this one. This we will rewrite it here, okay? But we will rewrite it in a way similar to the. We will transport this over the equations equal sign, and this over the other side. So it will change its size. It both will change its signs, and you see we have 2, 2, and 2. We could multiply that by 2, and that 2's will go, will vanish, and now we'll have this situation here. Now we again put m1 in front of brackets here and m2 in front of these brackets, and as you can see here, this is the how do you call this? I just look at the Google, and you call this thing a difference of two squares. Imagine that. Okay, now difference of two squares, you can write it as this one. First one minus second one is equal times first one plus second one. Same is here. This minus this times this plus this. That is expansion of this situation here. And now you see up there, this situation is this one, but it's equal to this situation. You see that? What does it mean? It means that you could just cross them out. You can divide both of the sides with those two things. Why? Because they are equal. So you have these equations. You have just, and all of this will become just this equation here, and this will be a second equation for our calculation. So that is simplification. We are going to use simplified equations. So this is from the momentum conservation, and this equation is from combination of momentum conservation and energy conservation. This holds always when you have elastic collision in one line, in one direction, so to speak. Okay? Now, you could put all of these things here, 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 and here, here, and here. All of these things that you have, you could, now you could put just numbers here, 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 and here, here, and here, and you will have two equations with two unknown quantities. That would be easy to solve, but like I said before, we are the teachers and we like to complicate things. So okay, this is informational that I talked before, first part, but we will express V1 after collision. What will happen then? Those first equation is equal, combining those two equations, of course. From the second one, V1 prime is just this. What does it mean? We've just transported this over the equal sign, that become minus. And then what we did here, okay, we rewrite this as this one, okay, and this we transport this over this equal sign, okay, and now what with this, we rewrite this equation here, but instead of this situation here, we write it all this expression here. And of course you have those two more. So we rewrite this equation here, but instead of this equation here, but instead of this situation, we write all this expression here, and you have those things too. Okay, and then we rearrange somewhat. We little rearrange this. Why? Because we want to separate those things that are known to us. We transport this over the equal sign, and now we put it in front of the brackets. You have this one. Now it's only this is unknown in this equation, so we will divide everything that's come here with this, that is written here with this. So we rewrite this equation as this one. So this is unknown. Or you could write this one like here. Or if you play around with this a little bit, you will get this equation. So now this equation is something that is used widely in these problems, but this is how you get to it. And now you just need to rewrite the data. But bear in mind that you have to, okay, this mass 1, mass 2, mass 2, mass 1, mass 1, mass 2, mass 1. This is velocity, speed of the first, okay. This is 2 times mass 2, and mass 1. That is alright, but when you're writing these speeds here, you bear in mind its signs. If it goes to the left, you put minus sign, go to the right, you put plus sign. And we have that speed of the first glider, it's negative 3.355 meters per second. What does it mean? The magnitude of the speed is this one, but because it's had minus sign, that means that it goes to the left side. Not similar to the derivation of the previous equation, you could derive this too, and that would be a first speed. And second speed, you could get similar to the derivation up there. You can derive this equation, but you don't have to do that anymore. You could just use what equation? You could use this equation here, or similar to this one. Now unknown is v2, and we just calculated this. We have this and we have this, so it would be easier. But sometimes it may be suitable to know. You could derive these equations here, similar to the one, and I proposed you to do that just for practice. And when you place, this is time here, when you place the numbers, corresponding numbers, well, look here, Genius didn't write here dimensions of the speed. That is necessary. All kilograms will cancel each other, but speed will remain in that you have here. So, me, the genius again, same mistake. Meter per second is be written here, and meter per second needs to be written here. So, you get this. Magnitude is this, but minus sign is also indicate that it's going to the left. So, both of these gliders after the impact go to the left. Okay, now let us test this. Is this right or not? Okay, let us see what it is. Okay, what v2 prim is. Okay, I don't have enough time. There's 15 minutes limit to the videos, so you could put back all of these equations back into these two and just test it. Is this correct or not? This is prior to impact, and this is prior to impact. This is prior speed of the first glider, speed of the second glider. This is first of the speed of the first glider, speed of the second glider after the impact, so on. All put on us. So good luck with this.